Hello, everybody. Welcome to Quantitative Techniques, Political Science 7202, Snow Day Edition. That's right, it is looking, well, hang on, let me take you with me. Come with me on this journey. Supposed to be 8 to 14 inches, so I received a couple of emails last night and actually leading up to yesterday, asking about, oh, are we going to have class because I live here or there and it's going to be a little bit tough. And I decided, let's just keep everyone together and have class online. And then, of course, 30 minutes after I sent out that email, Northeastern did make an official cancellation. But, we're a little better than that, so no worries. Here's a cool little graphic that I saw not too long ago. And it's an infographic of the MBTA subway system, and it's showing you based upon time. So it radiates out from the center, and each one of these large rings represents a 5-minute span of time. So you know how long it would take for you to get from, let's say, Oak Grove or Heath Street, Cleveland Circle, Boston College, etc., to get into the center and to go back out again. Pretty neat. Here's a fun little graphic that I saw. This is what dogs sound like in 14 languages. How many do you know? So we're used to like wolf or bow wow for an American dog, but in Chinese it's a wong 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 or wah 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 wah, or wan in Japanese. Very interesting. The same thing can be shown using mice. Of course, it's squeakity squeak, squeakity squeak for us Westerners, but there are other sounds that mice make. Very curious. Of course, here I am, shoveling, doing my thing, doing what I do best. So this was asked last week, and I asked a few more people about it just because I thought it'd be fun, and these are the responses that I get. Jarvis is charismatic, charming, snarky. He's basically a smart, talkative puppy that wears vests and bow ties. Bubbly, caring, immature. Fun, carefree, well-dressed. A man-child dork and a mountain man. Happy, preppy, constantly barefoot. Enthusiastic, well-informed, and passionate. So let's go over our homework. Please have your homework ready to follow along. If you did a good job, hey, great. Pat yourself on the back. We have a long string of numbers. Piece of cake, how to get the mean, median, the mode. Just add all the numbers up together, 5, 10, 10, 15, 15, 20, 20, etc., etc. Divide it by the total number of numbers that you have, and then you'll get the mean, or the average, 58.17. To get the median, you put them all in a row from smallest to largest, and you'll find that in between are two 70s, so our median is actually 70 in this example. And then the mode is the most frequently occurring number, that is 75. We have 6 75s in this group. We have different measures of central tendencies, and they are all affected in different ways based upon the way the numbers are arranged in their diversity and their spread. Obviously, the mean can be affected by outliers very strongly, whereas the median is not, and the mode is just showing you which number shows up the most. What this tells me is there seems to be more of a skew towards smaller numbers in this distribution compared to the larger numbers. We do have a nice range from 5 to 95, a range of 90 for these numbers, but they're not so evenly distributed or spaced out in a consistent way. They are more kind of front-loaded, which is why the mean is lower than the median, the mode. One possibility. So this one is asking about the number of participants in a lecture. I believe it's a political science lecture, and we're trying to figure out how many to kind of purchase for each year to anticipate the number of people coming. So we got one year was at 50 participants, 30, 20, 30, 40, 70, 60. And what this shows is that it's a big, it's a big range. So we'll do the mean, and we get 45. Add them all up, take 10 years, divide by the 10, and you get 45. We get the median, 40, the mode, and the range. And then here's where we get into the standard deviation and the variance. So to get the variance, you're going to take all of those numbers and put them in a column. All 10 of them, 20, 30, 30, 30, 40, 40, 50, 60, 70, and 80. And then you're going to put the mean in the next column, which we already calculated out to be 45. And then the third column is the x of I, the number you're looking at, minus the mean. And the fourth column is just that same number squared. So the first number that we have is 20. Subtract the mean from that, gives you negative 25. Square 25, and you get 625. Do that for every one of these 10 numbers across 10 years. The sum of the sigma, that little e, is 3,450. To get the variance, you take that sum and divide it by your n, or your number of numbers. In this case, we have 10 numbers corresponding to 10 years of lectures or symposiums. So that gives you a variance of 345. And then take the square root of that, 345, to get the standard deviation of 18.57. So what this tells us is that we have quite a large range in terms of attendance for this symposium or for this lecture. So if you do 45 minus 18.57, you get 26.43. And if you do 45 plus 18.57, then you'll get 63. So you have anywhere between 27 to anywhere between 27 and 64 attendance, corresponding to 68% of what is typical in terms of the standard deviation. Remember, within one standard deviation captures 68% of the population. So 68% of our attendance will be between this mid-20s to mid-60s number. And what this tells us is that it will be very difficult to kind of plan ahead to figure out how many people to prepare for these lectures. You can say, oh, well, we should just overshoot. But then what if the budget's really important for your particular department? Then, okay, maybe we should undershoot. But then you risk alienating people who are showing up in larger numbers than expected. So really the right answer for this is it kind of depends on your budget and your department and your priorities for planning this lecture. So let's talk about blizzards. Here are some interesting things that are prioritized in grocery stores when you have a really bad blizzard. Whole milk sells out. No one wants the skim. If I'm going to die of hypothermia, I'm going to drink whole milk. Or how about unsalted butter? No one wants that. I want salt when the snowpocalypse comes. Also, no minty chocolates, as you can see. And not knotted challah rolls. I want the regular ones. And none of the good for the planet recycled paper towels. We want the bleached white brawny stuff. So one question that's come up is, are we sissies? Basically, have we become so tuned to having snow days and to cancel school so easily? Our state and most states do not actually collect snow day information. Our individual schools may provide information on the dates of our snow days, but not the actual snowfall total. Schools these days tend to start before Labor Day as opposed to after Labor Day. So really, we have extra days already built into the calendar. And overall, the weeks of snow that we've had has gone down since the 1960s. However, the number of cars and students have been on the increase. So if you think about it, if we have, let's say, 10 inches of snow today, that's affecting more drivers than ever, more students than ever. So it's almost like individual snow is more potent now because we have more people in, for example, Boston. Well, they did this really interesting study, Joshua Goodman at the Harvard Kennedy School, called Flicking Out Snowfall Disruptions and Instructional Time and Student Achievement. And basically, summarize it all, they found that snow days have no negative impact on learning because they kind of just pick up right where they left off. And remember, when we're trying to make data and assessing data, we call our own shots largely based on an accumulation of data, and everyone knows it. Couple of tech tips for you guys. We have an address bar hack. If you just want to go to the address bar in your browser, just push Command or Control L. That'll jump right to the browser bar and you can start typing. You can also copy and paste text into the address bar, and then you could copy that and put this into Microsoft Word or whatever if you want to copy some text and you don't want to copy the formatting. The URL, the address bar, is actually unformatted. This is Tab Expose. It's a Chrome extension that allows you to visually see all of your tabs that are open at any given time. This way you don't need to cycle through and see what's what, or maybe sometimes you have so many tabs that they get so cramped you can't even read the labels anymore. Tab Expose will allow you to see a little snapshot of each tab so you can navigate quicker. Maybe you have the opposite problem though. You have too many tabs. Well, here is one tab. It'll take all your tabs that are already open, as you can see at the top, and it'll consolidate them into this nice little list in a single tab. What it does is it kind of saves the URL, and then you can go ahead and pick and choose which things you want to restore them all, or delete them all. This just helps you tidy things up if your browser is running a little bit slowly. Here's a fun little thing that I ran into. There are two kinds of people in this world. Apple and Android. Coffee or tea. People who carefully, mindfully remove each individual block of chocolate, and then savages who just bite into it. People that eat pizza the normal way, without that garbage crust, and people that like to eat garbage. I eat crust. Individuals that only look at what's on the menu, and people that only look at the prices of what's on the menu. Tidy fry people, messy fry savages. And of course. So here's another tech tip for you guys. This is called the Pomodoro technique for productivity. What the Pomodoro technique allows you to do is it helps you work in little bite-sized periods with built-in breaks. And if you do enough of these Pomodoros, or bite-sized periods of work, you can take a longer break. There are lots of apps you can download to do this, but really all you need is a timer. What's a very typical one is to do 25 minutes of work, followed by a 5-minute break. If you're able to get 5 or 6 of these done at a time, you could earn yourself a half-an-hour break. It's all really based upon your own preferences for figuring out what is most productive for you. But for me, I'll do about 25 minutes of work, take a 1-minute break, and then after about 2 hours, I give myself a 15-minute break, just to stretch and stuff. Not too bad. Works really well if you're working on a dissertation. So here's something that I thought about the other day, and it was stirring. And I know I saw this nice little study where they found that if you're going to be stirring your coffee or your tea, the best way to actually stir, scientifically speaking, the best, most effective, most efficient way to stir is not in a circular motion, but rather a kind of back and forth motion, because it creates more turbulence and thereby allows things to mix with the fewer necessary amounts of kind of strokes. I would like to counter that and say that, yeah, maybe scientifically speaking, it is more efficient, but we will never see this becoming a thing, because when we're stirring, we're not really going for efficiency. We're just stirring to mix things together with the least amount of effort and thought. When you're mixing, going back and forth, creating that extra turbulence, you're more likely to spill, and also is louder, makes more noise, that kind of thing. But if you're stirring using the traditional stirring method of going around in a circle, yeah, maybe scientifically speaking, it is more work, but it's more thoughtless. And we're able just to kind of do it without having to concentrate on it, without worrying about spilling, that kind of thing. So when someone says, oh, it's less work, what is their definition of work? Because if they're saying less work in that the amount of time it takes to stir something, yes, going back and forth is the best way. But if you're thinking, oh, less work is in how much it actually takes out of you to use a spoon in such a way, well, I'm just going to do it the old-fashioned way. Here's another funny little thing that we saw. In America, in the United States, boys are diagnosed with ADHD more than girls at nearly almost 2 to 3 times the number. And this kind of started when someone told me, "Oh yeah, you know, boys are just more rough and tumble. Boys will be boys, that kind of thing." And I thought, that makes no sense. So partially the reason why boys maybe, and there could be a genetic reason, of course. Part of the reason why boys are more likely to be diagnosed than girls with ADHD is they're just more likely to be taken to the doctor because that's just the kind of behavior that boys are expected to have. So if a boy is expected to have that kind of behavior, then they will look for a means to correct that behavior. Whereas girls, well, we don't expect girls to act out the way that boys do in regular society. Yeah, right. But because of that, maybe you're less likely to take a girl to the doctor because you're afraid of, oh no, my daughter's weird. I don't want anyone to know about that. Whereas because the stigma is so much that boys are more likely to act out and have issues with concentration and paying attention, it's just very easy to just go and say, oh yeah, I'm getting my son checked out for ADHD, no big deal. But a girl, it might be a big deal. So they're less likely to be taken to the doctor to be diagnosed. There's an interesting thing about the pay gap between men and women. They say women make 20 to 30% less than men. And that is true. However, there are other things that we should look at beyond just money. Because remember, money is not the most important thing in life, though some people may think it is. There are some things that men and women are looking at that are different. So, for example, women also are usually concerned about other benefits besides just the solid income or the salary that they're going to get. So, for example, maybe how good is the maternity leave from one firm compared to another? Maybe you're more willing to take a bit of a pay cut in order to have a longer, more supportive amount of maternity leave built into the plan of your contract. Another thing that we have noticed is that men tend to negotiate more on their salaries than women, and this is almost like a self-fulfilling prophecy, because if women think that they're going to be paid less than their male counterparts, then what happens is, well, I'm expected to get paid less. So if I get an offer, I should just take it because that's the best they're going to get me as a woman compared to a man. Whereas men are like, oh, they don't have to think about that. So they just go ahead and damn it. Get downloading with SPSS, shall we? We're going to head over to mynu.nu, those of you that haven't done so already. I'm going to kind of go through the process so that everyone can follow along. If you have not installed SPSS by now, really shame on you, because I've given you lots of opportunities, but don't worry about it. We're just going to go through it together. So we're going to head over to self-service. Over here is software downloads under the second box, class resources, studying class resources. There's another section down here about free and discounted software. Please skip that. Head over here to software downloads. From here, you can choose SPSS that is appropriate for your computer. I'd say anywhere between 21 and 23 is fine. You don't need 24. So you can get SPSS 23 or 24, whatever, for Mac, or 23 for Windows. Then you're going to click continue. Choose the right version. This is all just typical blah 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 stuff. You can click accept. Choose the installer, please. And then here in this little box, it will tell you some instructions. Please follow those instructions. The most important thing is, of course, this license code that you need to copy. Please copy that license code and put it somewhere safe, like in a notepad or WordPad, because later you're going to need to copy and paste that into your SPSS licensing software. You could probably just leave this window open if you want, so then you can just access it later. And you click download, it'll go down there, and these files are anywhere between 600 and 800 megabytes, so it's going to take a little while. Make some coffee, come on back, and install your software. If you have any questions, please let me know. So this is SPSS. It has two views, a data view and a variable view. In the variable view is where we create our variables. This is where we put in the questions that we have, for example, for a survey. Your age, your gender, your political party affiliation, all these kinds of things. Or later on when you're doing your own research, you could put in all the variables that you're looking for either the midterm project and eventually the final project. So a couple of ideas that you guys can have. Some people have done Will Ferrell movies. Some people have done highest grossing films, TV shows, music, favorite music, types of food, restaurants. I had a couple of students do things on public transportation. It really is whatever you feel like doing, so please go ahead and feel creative to do the research that you want to have fun with. So here's the variable view. Let's just pretend we have a question like, what's your favorite color? Please remember that you need to do an underscore if you're going to put in a space. Now, color, obviously, is a nominal level of measurement, so I'm going to label that thus. You can create a label here, what your favorite color. And then from here, you can click in your values. This is going to help you input your data into SPSS because it's all done through numbers. So, for example, you might type in for an individual 1 for red, 2 for blue, 3 for green. And then you can have some numerical variables as well. So maybe commute time. What is your typical commute time? Now obviously, because commute is if you're going to go by, let's say, minutes, that's a numerical or scale level of measurement. So I'll click that one. So here's my data view with my two variables, favorite color and commute time. I could put 1 for red, 2 for blue, or 3 for green, and then your commute time. So for example, out of those three, my favorite color is red, and my standard commute time is about 30 minutes. For someone else, maybe their favorite color is green, and their commute time is 45 minutes. Now obviously we'll have a lot more variables putting together for like a project or for any research, but just to give you an idea of what it looks like, adding two variables in there is a good start. Then maybe you'll have an individual who likes blue and they have a 60-minute commute. Here's our class survey, and as you can see, we have well over 200 observations or cases, in this case students. Oh wow, 343 students in this survey over the last few years, and these are all the variables on the top. As you can see, many of them are scale, but we have a few nominal and ordinal ones thrown in. For your midterm projects, which will be due on the 23rd, you'll be putting together an SPSS document with 30 observations, otherwise known as cases, with 6 variables, 3 categorical, 3 scale, with definitions of every single variable, charts and graphs, and your descriptive statistics. Let me show you one that I put together years ago for actually when I took this class as a master's student. So I did the top 30 grossing films of 2007. And what I have here are these are my variables in the variable view. I got my studios. So here's like, I did 1 for Sony, 2 for Paramount DreamWorks, 3 for Buena Vista, 5 for Universal, 8 for Fox Searchlight, etc., etc. Domestic gross. So this is like a code for the variable, and then in my label I could write in a more detailed definition of that variable. Domestic gross in millions, obviously that is in millions, so that's going to be a numerical level of measurement. Opening weekend gross in millions, that will also be a numerical level of measurement. Total theaters featured, number of theaters at opening weekend, months in the theatrical run, leading character, male or female. I chose 1 for male, 2 for female. The MPAA rating, G, PG, PG-13, and R. 1 for PG, 1 for G, 2 for PG, 3 for PG-13, 4 for R. The production budget in millions, obviously that's going to be a scale level of measurement. Running time in minutes, that's also numerical. Genre, sci-fi, 1. Comedy, 2. Action, 3. Drama, 4. Fantasy, 6. Adventure, 5. Rotten Tomatoes rating, that is also numerical. If the movie is part of a standalone series, or if it standalone movie, or if it was part of a series, 1 for series, 2 for standalone. Lead actors or unknowns, 1 for stars, 2 for unknowns. Live action, 1. Animated, 2. So that's all. This can be numerical. Rating is given by Yahoo users. I made this an ordinal level of measurement, A plus A, because Yahoo Movies uses a grading system, a lot like, school. A plus A, so I made that into an ordinal level of measurement. Did the film have a soundtrack, and if it was an Oscar winner? These are all the movies. And this is me trying to figure out, maybe certain genres tend to make more money, or maybe certain, maybe running time has an effect on, or is just connected to, has a relationship to the gross. And I found a couple of things. We'll talk about this in class, but it was a very interesting project for me to put together, and I want you guys to have fun with it as well. Don't feel like you need to do movies or music or anything of that sort, but kind of pick something that you're interested in, because you're going to be looking at it for a few weeks. And then for the final project, you guys will be doing surveys. So those will be a little more in depth, and you'll have some really solid analysis from those from the data that you put together. For the projects and for the assignment, which will be using our class survey file, you need to create charts and graphs and do descriptive statistics. Descriptive statistics is just looking at your data as a snapshot. So let's take a look at our class data. Descriptive statistics is done in 2 steps. The first step is for the frequency data, which is for all of the categorical levels of measurement, and the descriptives for the numerical levels of measurement. Head over to Analyze, go to Descriptive Statistics and Frequencies. Before, I went ahead and labeled everything with as ordinal or nominal. So I can now just really quickly pick for frequencies, which is for categorical data, all my categorical values, all my categorical levels of measurement, variables. And then from here you can go to your statistics. And obviously, because this is categorical, it wouldn't make sense to get like standard deviation or minimum or maximum or the range. They'll be useful for when we look at the descriptives. However, you can go to charts and then choose, like, for example, a bar chart. Click OK. SPSS will run its thing into the output window. And now here you'll see our data. Each individual variable will have its frequencies tallied, basically. So out of 343 responses or cases, we get 133 male, 208 female, with 2 missing. Same with degrees. We have political science undergrads 150, MPA graduate students are all over here. Political party affiliation, we have 115 strong Democrats, which creates a valid percent of 36% of everyone in this sample in the distribution. 21% weak Democrats, or 67. 19% independents, 7% weak Republicans, and 3% strong Republicans, or 10 students. Take a look at all of these. They're pretty fun. Just kind of go through. Here are my bar charts. Male, female, just showing you each of the individual answers. So here's an interesting thing. Here, we showed this in class already, but if there's a number that was typed in that does not correspond to any of the created labels or items, it'll stand out as sore thumb. So what this tells me is when someone was entering in the data in SPSS, they typed in 7 or 8 by accident because we only created 1 for Protestant, 2 for Catholic, 3 for Jewish, 4 for Muslim, 5 for other, and 6 for none. So these are miscalculations. And it's very easy to just go back here. Maybe we'll go into religion, and you could right-click it and sort ascending. Or actually, no, we should sort descending. And here's our 7 and 8. I can go ahead and just delete it and then save the file. And then those missing values, those incorrect values will be gone. Very easy to troubleshoot. So these are all our categorical levels of measurement. Here is how you would analyze and create descriptive statistics for your numerical levels of measurement. Head over to Analyze, Descriptive Statistics, Descriptives. Give these nice little rulers, which are scale or numerical levels of measurement, grossing films, data set, and you can go into the options and do your standard deviation, minimum, maximum, range, that sort of thing. It's much cleaner to look at the descriptives. It's all in one nice little table. So among these movies, the average gross was 178 million. The opening weekend gross was 51 million average, and you also have the mins and the maximums. You can take these and just copy and paste them into Microsoft Word. You could also choose to go to File and Export. And then from here, you can export this as a Microsoft Word document and just copy and paste the individual sections. Please, for when you submit homework or your projects, only give me the data that is necessary. So for example, if I ask you for descriptive statistics, show me this box. You don't need to copy this section or this or any of this, I would call this junk output. Just give me the bare essentials for my descriptives, for your descriptive statistics that you need to give for your midterm or for this homework assignment. So that pretty much covers the frequency table and the descriptive statistics. You should be able to do that for yourself on your installed SPSS. Please let me know if you have any questions, and I hope you guys have a good snow day. Take care.
Come to decide that the things that I tried were in my life just to get high on. When I sit alone, come get a little on, but I need